Hello everyone, welcome back to assignment 2. I'm Satvik, I'm one of the TAs, and I will be giving you a thorough run through of every question and how you can approach it. Like I mentioned in the first assignment, even though we've given tools like Godbolt, I will not be using any of them and I will be just solving it from a logic point of view. So yeah, let's get started. So given below is an line assembly code and analyze it and answer questions. So like how I did it for the last time, I will just write down what each thing is storing. I'm just using EBX, ECX, alright? So the first step says I have the value X, alright? So what I will do first is I will first write down every single expression in terms of variable and I will use it to solve later onwards. So EX first has the value X. Then I get this is step 1. Step 2 says move EBX comma B. Then I XOR EAX comma BBX, which basically means I will get the value of XOR of EAX and EBX will be stored in EAX, which means EX is now EX XOR B. And then I or this is done. I or EBX comma X, so it's gonna be B or X. Right, this is done. Now I'm gonna AND EX comma EBX, and basically this means EX gets the value of the AND of EX and EBX. So this basically means I'll have X XOR B and B or X. Alright, this is done. Then I say that EBX takes the value of A. This is done. Move ECX comma Y. ECX takes the value of Y. And XOR EBX comma ECX. Since EBX stores value of A, ECX stores value of Y, then XOR EBX comma ECX will just basically mean EBX stores the value of XOR of A and Y. And finally, I OR EX comma EBX, and since I don't have space there, I will just write it down here. EX continued. At the end, I have X XOR B and B or X. And finally, I have OR of EX comma EBX, which is A XOR Y. Alright, so I have X XOR B ANDed with X or B ORed with A XOR Y, which basically means my option is option B. Alright, so now which of the following what are the value of EXB? Alright, so now let's substitute values and let's solve individual block at a time. I'll just solve this here. X XOR B. What is X? The value 3. So that's nothing but 0, 0, 1, 1. XORed with the value B, which is nothing but 5, which is 0, 1, 0, 1. Which is nothing but 0, 1, 1, 0. Then I have B or X, which is basically, okay, I'll just write this down XOR here. And then B or X. B is nothing but 5, which is 0, 1, 0, 1. Or X is nothing but, sorry, I'll just write or like this. So now X is nothing but 3, which is nothing but 0, 0, 1, 1. And I'm ORing the two. That means I'll get 0, 1, 1, 1. And now, okay, I'll just solve this first. A XOR Y. A is nothing but 14, which is nothing but 8 plus 6. So 1, 1, 1, 0. And Y is nothing but 7, which is 0, 1, 1, 1. And I'm XORing the two, so I'll be left with 1, 0, 0, 1. Alright? Let's just verify that again. X is nothing but 3, B is nothing but 5, XOR of the 2 is nothing but 6. Then B or X. B is nothing but 5 and X is nothing but 3 and the OR of the term is nothing but 7. Then I have A XOR Y, which is 14 XORed with 7, which is nothing but 1, 0, 0, 1. Alright. So now let's just do the AND operation first, and the ANDing of these two is gonna give me 0, 1, 1, 0. And then when I XOR, or this with this, I'll end up with 1, 1, 1, 1. Alright. So final answer is nothing but 15. Alright. Let's go to the next question. It's another similar type of question. I'll just write down the values this time. So EX holds the value X, which is nothing but 3. Then I multiply Y. Y is nothing but 2. So then this is going to become 6. Then I add EX comma A, which is nothing but I'm gonna add 6 with A, it's 7, so 13. And then subtract EX comma B, which is nothing but 13 minus 6, which is going to be the value of 7. So what is the value present after the entire thing is done? Nothing but 7. Alright. If in the above code the value of X is replaced with 0x, so on and so forth, what is the value present in register EAX? Okay, so let's see in the first step, I have EAX is nothing but EX comma X. So X is nothing but this one. So let's just say right here EAX holds the value 0x 8 1 2 3 4 6 7 1 2 3 4 5 6 7. Okay, and okay, let's just do this. Multiply y is nothing but 2. And if you remember from the first assignment when we had such a case, so 8 here is nothing but 1 0 0 0. I'll just write this in a different color. It's something about 1 0 0 0, and the moment I shift it by 2, multiply by 2 or just left shift once, I will just have to add a 0 at the end, which means this one will go to my EDX and the remaining are just going to remain in my EX. Okay, so EX will now hold the value of 0 while EDX will hold the value of 1. Okay, and then I add EX comma A, which is nothing but EX plus 7, which is nothing but 7, and then I subtract EX from B, B from EX, which is nothing but 7 minus 6, which is nothing but 1. So the final answer is 1. Alright. Okay, so the next question says, which of the following can be used to detect the end of a string present in the data segment? So at the end of the string, what basically is stored is the value 0x00, or we represent it as \0, okay, as a string. Sorry, yeah, \0. So let's go over through the options actually. So compare byte pointer EBX 0x00, where the pointer to the character is loaded in EBX. So if the pointer to the character is loaded in EBX, that means this this square bracket EBX is nothing but giving me the value. Byte pointer of square brackets EBX is nothing but giving me the value at the end of the string. And if that is equal to 0, then I have come to the end of my string, which means this is the right option. If I'm able to compare the final value with 0, that means I'm getting the right way. Compare EBX, 0x00, where EBX holds the value of the 4 characters at once. No, this is false because only the last character has to be equal to 0. Only in that case will I end up doing the work that I want to. So this is wrong, and clearly then this is wrong because none of these is not an option. And compare BL 0x00, where the value of a character is stored in BL. This is the main option, and to be honest, if you think about this idea, this is nothing but the byte pointer EBX and BL are basically similar ideas, where BL just stores the final character while the byte pointer EBX points to the final character. So they work on similar ways. So the answer is A and D. Next, let's go to this question. Given below the C code, analyze it and answer the questions. Okay, which of the following statements do not get compiled by assembly when compiled for maximum optimization? So what happens when you're doing maximum optimization is the compiler just looks at what it wants to return, and then it'll do the operations only to achieve what it wants to return. So for example, here I want to return the value of P. So I need to do this P equal to Z plus A, Z by X is must, and Z and X are both inputs. So all I really need right now is statement 5 and 7. Okay. So which of the following statements do not get compiled? Then you have your 2, 3, 4, and 6. So here I have 3 is not going to get compiled. 4 is not. 4 and 6 are both not going to get compiled. So only statements that are going to get compiled are 1, 5, and 7. Okay. If statement 7 was changed to return S, which are the following? Okay, let's go through this again. If this were made return S, okay, then in which case I will need this. I will obviously need this. S equals to Z minus A. So Z is a argument. So I will not have to do anything. But A, for A, I will need to do this step also. and z and x are again input arguments, so we don't really care about them. So all I'm going to be needing are 1, 4, 6 and 7. So which of the following are not compiled are 2, 3, 5 and 2, 3 and 5. So here the right answers are 3 and 5. Okay. Given below is a C code, analyze it and answer questions 8 to 9 based on it. Okay, how many basic ALU operations are performed? So let's just go through what is performed. You have n plus 5. Again, this is talking about the fact that I'm talking about unoptimized. So 3 plus 5 I do, p equal to x by n I do, t equal to this I do, and here I'm going to do 2 of them. So 1 plus 2 plus 3, 1, 2, 3, 4, 5. So I need to do 5 operations. And how many basic operations if in maximum optimization? Okay, so when I'm doing maximum optimization, let's go back to what we needed. We had to do this step we need to do. So because of which I need to do e equal to y into p plus t, for which I need to do both p and t. And the remaining steps can be ignored. So here I have 2 ALU operations which I must perform. And then over here, I technically do not need to do two ALU operations. I just need to do one, because when I'm doing a division, I get the quotient as well as remainder stored. So just using one division, I get both p value and t value. So I just need to do one operation, and that will give you my both x by n and x percentage n. With x percentage n is nothing but your remainder or your modulus function. So the answer for this question is 3. Alright. After the execution, let's go to the next question. After the execution of the following code snippets, which is the value by which the variable PA is okay. Cool. Okay, so the first question says, let's consider them separately. You have int star PA equal to 0. So since it's an integer and it's a pointer, integer is basically 4 bytes. And if I'm doing a pointer arithmetic, which basically means point to the next pointer, I need to skip over 4 values, or basically increment 4 values. So the left side is going to give need an increment of 4. Over here on the right side, I only say increment EX. If I want to, even though this is a pointer, I'm just asking the compiler to just increment. For example, let's just say here, in case of the left hand side, my assembly translation would have been add PA, 4. But here it's just increment EX is something but add EX, 1. So here I will add 4 and here I will add 1. So the correct answer is this. Alright, let's go to the next question. So here there's a C code given and there's a few questions asked on it. Which of the following is the purpose of assembly statement 3? Assembly statement 3 is basically this, which basically is like saying, okay, let's just go through the options. To load the register EDX with the value of C variable n. That actually is the right answer, because n is given as an offset of 8, and clearly this maps to this. Okay, so load the register EDX with the value of C variable n is correct. So obviously second option is wrong, because they're saying address of C variable n. That's not right. To initialize C variable parity, no, that is being done here because I'm defining to be 0. To load the register EDX with the value in the address pointed to by, no, this is definitely not right. So option A is the right answer. Next question is, which of the following statements implement the functionality of C statement 6? Parity is equal to negative of parity. If you look at the assembly code, this line 10 basically says XOR EX with 1. XORing a number with 1 is basically inverse. For example, let's just take the truth table. Let's just say I'm trying to find the output of X XOR Y. Okay, and I'll just say X, Y, and what's the output? So 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. So if you think about it, if both the cases where X is equals to 1, whatever Y has inputted, I'm getting the exact opposite of it. So if Y was 0, I'm getting output as 1, and if Y was 1, I'm getting the output as 0. That means anytime I'm XORing a number with 1, I will basically be getting the inverse of that number. So that is what is happening here, and that is what I need. So the answer is statement number 10. Statement 12 in the assembly code maps to. Statement 12 is jump not equal to. Jump not equal to is basically saying that if a condition is not met, I'm going to jump somewhere. So here I'm going backwards. This is similar to what we experience in the loops. All right, because my while loop is basically testing if my conditions satisfied, I will keep doing the statement, and basically jump not equal to here is achieving the same thing. So the answer is the while block, which is nothing but 4. Okay, answer is 4. If parity is caught from the main as shown below, it will print out output. Okay, so let's see the C programming. It's saying while I'll just clear this. While n, that means if as long as n is not equal to 0, parity equal to inverse of parity, and n equal to n and n minus 1. Okay, so let's start with the input value 7, and I will just write down the value of n here and the value of parity. All right. Okay, I'll just do one thing. I'll write n before, nb is n before the loop, and n is n after the loop. So n before the loop is nothing but first the input coming here. Just for clarification, n I'm referring to is in this function n. All right. So here the value goes in as the input argument, which means it takes the value of n, which is nothing but 7, and parity is initially defined at 0. But once I enter the while loop, I'll flip it. So I'm gonna go with 1. Okay, and n is equal to n and n minus 1, which is nothing but 7 and 6. 7 is nothing but 0, 1, 1, 1. 6 is nothing but 0, 1, 1, 0, and of this 2 is nothing but 6. Okay, now I come to 6, which allows me to get into the loop, and because of which again I invert the parity, which becomes a 0, and then now I have to add n and n minus 1. N minus 1 is 5 here, which is nothing but 0, 1, 0, 1, and n is nothing but 6, 0, 1, 1, 0. Okay, and adding these two is nothing but going to give me a 4. All right, now 4 is again greater than 0, so I go here and I invert the parity, 1 again, and then now I do n and n minus 1 here, 4 and 3, which is going to give me a 0. So that means I might get the value 0. And now next time I will not enter the while loop, and I will just come out and return parity. So the value of parity right now is 1. So the answer for question number 14 is 1. Right? Question number 15. So if the statement in the statement 1 of the C code is changed to bool of parity. Okay, so bool parity, short int. So int is taking up 4 bytes. Int is taking up 4 bytes, but short is going to take only 2 bytes. Okay, which means anywhere where n is referred. That means if you move to the assembly code, n is stored in the value edx. Technically speaking, because I only need 2 bytes, I won't have edx anymore. I will only have a dx. So everywhere that you see an edx, I'm just going to end up with a dx. So this is going to change. 5 is going to change, and technically speaking, even 11 is going to change. Let's just go and check what our options are there. 3, 5, 11, and 14. What is 14? Ret 0. Clearly, that is not going to happen because that has nothing to do with the input argument. So answer is just going to be 3, 5, and 11. All right. So answer is 3. 3, 11, and 5. All right. Let's go to the next question. So this is a example of swapping. Let's see if the swapping works or not. So here I'm basically giving the value a is equal to 26 and b equal to 53, sorry, and I'm passing them straight up into the function. So here x holds the value 26, b holds the value 53. Now I'm going to say my temp holds the, after this I'm going to say temp holds the value of 26 plus 53, which is nothing but 79. And then y is going to hold the value of temp minus y. Temp is nothing but 79, so y is going to be temp minus, so 79 minus y. Okay, my bad here. Y is equals to 53. So y is nothing but temp minus y. So 79 minus 53, which is nothing but 26. And here I'm saying x is equals to temp minus x. Temp is 79 minus x is 26, so 53. And I'm returning x, which means I'm returning 53. So yeah, but if you think about it, this is just changing the values of x and y locally and not really affecting the global. In the main function. So my a and b are going to be remaining the same. So it's nothing but 26 and 53. And the return value, which is nothing but return value is x, which is 53. So return value is that's going to be printed is 53. So the right answer is 2653 and return value is 53. All right. Let's go to the next question. What is the value in the C variable a and b after statement 6 executes? Honestly, a and b are not being affected because what I'm passing here is nothing but just the values and not the pointers by themselves or the variables by themselves. So a and b are just going to remain 26 and 53 all through. Okay, let's go to the next question. Mark the valid output when will be printed. Okay, let's go to this. So here, instead of passing just the values, I am passing the addresses. Okay, so basically x holds the address of a, y holds the address of b. Okay, that means this temp is holding the address of b, which is slightly confusing to understand, but let's just keep it aside. And now I'm saying that star y equal to x, star x, and just know that star x holds the value of a, which is nothing but 26, and star y holds the value at b, which is nothing but 53. So now what I'm going to do is this step where star y equal to star x, which means just the value at b is going to be changing to this one, which means the value at b is going to be changing, right? So that means b is now going to be taking the value of a. So that means b is going to take the value of a, which is something but b is going to take up 26, and then a is still going to be 26, and then now they're saying the same thing, that star x, which is nothing but a is going to be taking the value of star y, which is nothing but b, which is also 26. So what they're going to return are both 26, 26. So print 26, 26. Now analyze the following and answer question 19. Okay, so here we have another case where you're again passing both the addresses. Now temp is holding the value at b, which is nothing but 53. Then y is going to take, which is nothing but here star y is nothing but b, which is going to be taking the value at a. Star x is nothing but the value at a, which is going to be 26. Then star x, which is nothing but a, is going to take the value of temp, which is going to be 53. So now a is going to be 53 and b is going to be 26, and that is what is going to be printed out. All right. So these are the right answers, and I hope you had a fun time learning. Thank you so much.